So to see that this is actually a nice way of living our lives, let's take a look at how we can invert this analysis matrix to get the synthesis matrix and the basis of these CDF22 wavelets. So to begin, let's take a look at some cheap tricks that we can use from linear algebra to make our lives easy. So let's suppose we have these block matrices. So I'm writing this matrix A, B, C, D, where now A, B, C, and D are not numbers, but they represent smaller matrices. So these are really, this whole thing are really a bunch of 2m by 2m matrices, but we're just kind of thinking about their quadrants as kind of like littler matrices of size m by m. If you have matrices that you're kind of conceptualizing in this way, then what happens when you do the matrix multiplication? Well, the upshot is you can do the matrix multiplication pretending that the entries are really just numbers. In other words, you get the same rule for matrix multiplication that you would if they were numbers. You take um, you take these two guys, you multiply by these two guys to get this expression here. You take these two guys and multiply by these two, oops, excuse me, and multiply by, I don't know, say these two guys to get this expression there, etc. There's one little proviso though, which is that order matters. These are matrices and not numbers. So when I write this expression, for example, AF, which came from like this term over here, the A was on the left and the F was on the right. And this is really not the same as FA. And if I, and the right one is AF because the matrix with the A on it is on the left, the matrix with the F on it is on the right. If you, and this is a kind of a nice shorthand way of thinking about matrix multiplication with matrices that are kind of built in this blocky way. You can kind of think about any 2m by 2m matrix, of course, in this blocky way, but sometimes it's useful and sometimes it isn't. Another super nice trick about these guys is that if you have a matrix like so many of the ones that we're thinking about nowadays, which is say a lower triangular block matrix, then if you take the inverse of that, it turns out that all you're really doing is taking the negative of this guy down there. You can just check explicitly using the rule up above that this actually is the inverse. And similarly, if you had an upper triangular guy, the inverse, again, is just by sticking a negative there. So with that in mind, we can now quickly figure out the inverse of our analysis matrix, which also goes by the name of the synthesis matrix. So to figure out, so remember that our analysis matrix looked like, what is it? It looked like you normalize after you update, after you predict, after you split. And you remember the general procedure is that when you are interested in taking an inverse of a matrix, and the matrix is described as a product, then that's the same as taking the inverses of each of the constituents in the reverse order. Okay, so the matrix inverse has to look something like that. Now, inverting a diagonal matrix is pretty simple, right? If your diagonal matrix looks like some, D1, D2, then the inverse is going to be the same kind of form where you've put an inverse on your diagonal entries. You can just check that explicitly. So doing the D inverses is no big deal. The update matrix looked like this IM script EU, which looks very different than my Roman U, notice. See, very different. It looks like that. And so the U inverse is, IM minus U, IM. And similarly, the P inverse, if you remember what our old P looked like, I had this P, oops, sorry, not P inverse, and minus P, like that, 0. Okay, So now we had very explicit forms for what these things actually were, right? Our script U, if I scroll back up here, was this guy right there. Our U was that. So just to be very concrete, just for a moment, I'll let you be more concrete by yourselves. Hint, hint, homework. U is, so original U very explicitly looks like an IM minus 1/4 IM plus 1/4 S, 0 IM. And so therefore U inverse is going to look like IM minus 1/4 IM minus 1/4 S, 0 IM. Okay, so how do you undo your update? Instead of adding to your first part 1/4 of the second part plus 1/4 of the shifted second part, you subtract those from the first part of the step. Okay, so what I'd like you to do then is write down a matrix form for the synthesis matrix. Go ahead and work out that matrix multiplication. Okay.